Welcome to saitechinfo, dear UPSC, tnpsc, NEET and JEE aspirants and school and college students.
Hi my dear young friends. Today I will be explaining about the atomic structure. These are all the very important formula. You have to by heart all these formulae so that it should be very useful for solving the problems associated with the atomic structure. Before starting this topic, let us have some introduction about the atom. As we all understood, atom is nothing but the tiniest matter which cannot be further divided according to Dalton. And that is why he gave this name atomia. Tomia is divisible, atomia means indivisible. But later we were able to discover subatomic particles like proton, neutron, electron, positron, meson, pi meson, etc. After that, now we have clearly understood that atom can further be divided. In fact, it should be called tomia instead of atomia. But in order to honor Dalton, we are just maintaining this term. Now, let us consider the charges of all these particles, subatomic particles. We have the electron with negative charge. Proton has positive charge. Neutrons have no charge. When we consider the atom, it always maintains the neutrality by having equal number of atoms, protons and electrons. For example, let me consider oxygen atom. The atomic number of oxygen is 8. This atomic number is nothing but the number of electrons or number of protons because they are equal in number. Then when we talk about atomic mass, we include the number of neutrons and we don't consider the mass of electron here because they are negligible compared to the mass of proton. So we consider only the sum of number of protons and neutrons, and that is nothing but atomic mass, and it's also called mass number. Now let me throw some light on the atomic mass unit. This atomic mass unit is nothing but the reciprocal of Avogadro's number. Avogadro's number is something like, for example, if you have got 1 dozen apple, you can say 12 apple. 1 dozen lorries, you can say 12 lorries. So similarly, it's mere number. So it is useful to determine the number of subatomic particles or atomic level particles, that is very minute particles. So you can even call that is 1 mole of dust contains 1 Avogadro number of dust. It means what? That is 6.022 into 10 power 23. For example, when I say 1 mole atom, so how many atoms are there? 6.022 into 10 power 23 atoms. When I say 1 mole, that represents the Avogadro's number containing 6.022 into 10 power 23. Now let me compare the mass of hydrogen and mass of uranium. Mass of hydrogen is 1. Is it 1 gram? No. It is a 1 atomic mass unit. So it means what? That is, assuming that if hydrogen has 1 gram, uranium will have 235 gram. It means 35 parts. So it's only a relative atomic mass. Usually for calculating actually the relative atomic mass, we use a carbon-12 isotope. Now let me focus on this 1 gram of hydrogen and 235 gram of uranium. Suppose if it is 235 gram of atomic mass of uranium, means it will be looking like a potato, is it not? So truly speaking, it's not so. So it is a 235 atomic mass unit only, and you may be interested to find out the actual atomic mass unit. For example, when I say 1 gram of hydrogen, it means it consists of 6.022 into 10 power 23 atoms. So let us give in this way. 6.022 into 10 power 23 atoms of hydrogen weigh 1 gram. Then one atom of hydrogen should be what? 1 divided by 6.022 into 10 power 23. Is it not? So it roughly gives almost 1.67 into 10 power minus 24 gram. Then we can convert into kilogram. So 1.67 into 10 power minus 27 kilograms. So this is the what? The actual atomic mass unit. So when you say hydrogen atomic mass 1 means 1 into 1.6 into 10 power minus 27 kg. So now it is somewhat comprehensible, understandable, is it not? And when you take the atomic mass of uranium 235, then you can claim that uranium 235, that is 235 into 1.67 into 10 power minus 27 kg. Now we are able to appreciate the actual weight of the atom of uranium. I hope now you should be able to understand this subject very well. Now let me proceed with the various equations and various constants formula for atomic structure. Okay, right. The mass of electron, as I already told you, even though it is negligible, but it has got certain value, that is 9.11 into 10 power minus 31 kilogram. 10 power minus 31 kilogram. Mass of proton is 1.00727 atomic mass unit. It is given in atomic mass unit. You have to be very careful. So what you are supposed to do, if it is given in atomic mass unit, you have to multiply by 1.67 into 10 power minus 27 kg. Are you able to follow? Now roughly we can say 1.007 into or 1.008 into 10 power minus 27 kg. You just compare the mass of proton and mass of electron. So mass of proton is in the order of 10 power minus 27 and the electron is in the order of 10 power minus 31. You just believe that the difference is, this is 10 power minus 31 and hydrogen proton is 10 power minus 27. So the difference is 10 power 4 times. Is it not? Right. And that is why the mass of electron is negligible in this case. Now let me proceed with the photoelectric effect. What is a photoelectric effect? That is, it is the phenomenon of emission of electrons from the sheet metal on irradiation. Irradiation means what? When some light falls on a sheet metal, the electrons are scattered and escaping from the surface of the metal. Thereby, Einstein, he was able to, that is, find out an important equation based on photoelectric effect. So it is given as, that is, the work function, that is the energy required in this case. Work function is equal to Hc, where H is the Planck's constant and C is the Avogadro, speed of light. Speed of light is 3 into 10 power 8 meter per second. Divided by, that is Hc divided by lambda max, that is the maximum wavelength. Then Planck's quantum theory. According to Planck's quantum, that is E is equal to h nu, Planck's quantum. Quantum means it is a quantified energy. Energy in the discrete form can be called quantum or photon. So one photon is equal to h nu. Nu is a frequency. So nu is equal to c by lambda. So you can substitute this equation hc by lambda. Then the number of waves in orbit. This is also another important formula you have to remember when you go through Bohr's equation. So number of waves in an orbit is equal to the circumference of the orbit divided by wavelength. So this is one of the very important intermediate equations used in Bohr's hydrogen model. Then we have, according to Bohr's concept, that is we talk about the angular momentum, is it not? So this mvr is equal to nh by 2 pi. As you know, that is m, that is the mass of the electron, v, the velocity, linear velocity, and r, that is the radius of the orbit, the particular orbit, and n, that is the number, integer, h, Planck's constant, of course pi is constant. Then we should know that is lambda is equal to h by mv. This lambda is equal to h by mv. It's a very popular equation by de Broglie. So lambda here you can find, in fact, mv is the term associated with the matter, is it not? Lambda is the term associated with the what? Wavelength. So mv is nothing but the mass into velocity, that is momentum. So you can use this term p also. So lambda is equal to h by p. So it means de Broglie, he was able to prove that there is a dual nature of electron. So sometimes it behaves like a particle, sometimes it behaves like a wave. So he was able to relate these two aspects of light or electron, and therefore he was able to get this equation lambda is equal to h by mv. And according to Heisenberg's uncertainty principle, that is delta x into delta p is greater than or equal to h by 4 pi, where this delta x is the uncertainty in position and delta x is the uncertainty in its momentum. So it would be very difficult to identify the electron along with the parameter, that is momentum. So that is the idea of Heisenberg's uncertainty principle. Okay, and you should be able to understand the node aspects. So here the radial node is given by n minus L minus 1, where L is the angular mode and n minus 1, that is the total mode. And you should know something about the angular momentum of electron, that is given by the whole square root of L into L plus R into h by 2 pi. Then maximum number of electrons in n plus g shell, that is given as a 2n squared. So you have to remember nth shell. So maximum number of electron in the nth shell is given as 2n squared, and the number of orbitals in main energy level is given as n squared. Okay, so these are all the very important formula that is required for atomic structure part 1. So we have got some more equations also, but I am confining to part 1, the formula associated with the part 1 of atomic structure. Thank you for watching this video.
யாம் பெற்ற இன்பம் பெருக இவ்வையகம் என்பதற்கேற்ப please subscribe if you like our educational contents and share with your family and friends. Thank you for spending your valuable time.